Question 9. So Yared is making a door wedge and the cross section is shown here as a right angle triangle with a height of 3 and a base of 12. To find the length of side x, which is the hypotenuse, we're going to have to use Pythagoras' theorem. Pythagoras' theorem said if you square the sides and add them together, you're going to be able to find the length of that hypotenuse by square rooting the total. Square, add, and then square root. We're told here that our answer has to be to just 3 significant figures. So on my calculator, I get 12.36 and far too many digits. But for 3 significant figures, I'll just want to round that to 12.4. In part B, we're told that angle Y needs to be less than 15 degrees if this door wedge is going to fit under Yared's door. So this is going to be a trigonometry question. I get a choice of saw, ca, or toa, and by labelling the opposite and the adjacent is going to be a toa question. So I write it down without any numbers, just as in letter form. And then I put in my information. So tan of the angle equals the opposite divided by the adjacent. To get the y on its own, I've got to shift the tan, which appears on your calculator as tan to the minus 1. Type that into your calculator so that you can get to your value. And that comes out as telling me that the y angle is actually 14 degrees, which is less than the 15 degrees that is the maximum, so that's going to fit under the door. In part B, we're told that these two shapes are mathematically similar. This means that as we look at the old shape, which used to be 3 centimetres tall, they've multiplied that by something to make the height on the new shape. And the old shape, which used to be 12 centimetres long, they've multiplied that by something to make the length of the new shape. If we do the 4.4 divided by the 3, this is going to give us the scale factor, the magnifier or the multiplier that is going to increase all edges of the shape. So in the same way that the 3 was multiplied by 1.5 to get us to 4.5, the 12 will be multiplied by 1.5 to make that new base. So the new base needs to be 18 centimetres long. Question 10. A grass track is shown in the diagram below. This is the region shaded in the diagram. Each end of the grass racetrack is created with semicircles. The inner semicircles have a radius of 15 and the outer one have a radius of 20. Each of the straight sections of the grass track is 65 metres long. What is the total area of the grass in the 2 straight sections of the racetrack? You must show all your work in. So they've highlighted here that they're talking about the 2 straight sections. So I'll just highlight them on the diagram. It's going to be these 2 straight sections here. So by looking at the difference between the 2 circles, the track itself is 5 metres wide and those straight sections are 65 metres long. So that would be the grass area on one of the straight tracks, and there's 2 of them. So altogether that would give me 650 metres squared of grass. Part B, calculate the area of the grass track. So that's that 650 that I just worked out, but also the 2 semicircles either end. If I took the 2 semicircles either end and I put them together, then I would end up with a circle. So if I just imagine that for a second, there's the circle, and then the track would be the difference between the 2 circles. So this is the circle of 15, this is the circle of 20, and that track that's split between the 2 halves would be then the shaded area. So if I do a circle of 20 and found the total area of that, so pi times 20 squared. And then I get the smaller circle, the white circle has been cut out of the inside, pi times 15 squared. And if I take them away from each other and I type them into my calculator, this circle area works out to be 549.7 meters squared. But don't forget that we've also got the 650 from the two straight edges. So the total for the racetrack is going to be that 650 from part A plus that value that we've now got, 549 here. So that's going to give us the total of 1,199.7 meters squared. That's the total for the entire racetrack. Part C, the grass is to be treated with a fertiliser. It costs 20 pence for every 3 meters squared of grass. How much will it cost to treat the grass racetrack? Give your answer to the nearest pound. So 1,199.7 shared into allocations of 3 meters. Means that I need 399.9 bags of fertiliser, and they're all going to cost 20 pence each. So if I multiply that by 20p, that's going to cost me £79.98. But it says to give my answer to the nearest pound, so that's going to cost me £80. Question 11. Hot water is often stored in cylinders. The water in the cylinder is heated to use in the shower. A plumbing engineer wants to calculate how long a shower can be used continuously before the water runs cold. He uses the following formula. Lots of variables in that formula, and as you can see, they're all outlined by here. Daisy cylinder holds 300 litres of water. The temperature of the hot water in a cylinder is 60. The temperature of the cold water that feeds the cylinder is 8. The water in Daisy's shower is set at a temperature of 32. Her shower has a rate of flow of 26. Compare all that information to the formula above with all the different letters C, H, M, X, Y, T and F and what they represent. The question over here says use the formula to calculate the additional volume of water that feeds into Daisy's cylinder in litres, the number of minutes Daisy's shower will run continuously before the water runs cold, the C calculation and the T calculation. So I'm going to keep that page open on my exam paper and I'm going to put them straight into the formulas. So to start off with, C equals. So looking at our information, we're going to take the H value to be 300, the X minus M, think about what that represents, the 60, take away the 32. And that's going to be divided by the M value again, subtract Y. 32 subtract 8. I'm going to type that straight into my calculator, brackets, divider and everything else. And that comes out as 350 litres. They also, second bullet point, want me to work out T. T is a shorter question. The C that I've just worked out plus the H divided by F. So for my values, that's going to be 350 plus 300 divided by 26. Typing it straight into my calculator, that comes out as being 25 minutes. Question 12. Dr. Khan and her daughter Farrell have different opinions about the mean temperature in the hallway. Dr. Khan and Farrell record the temperature in the hallway at 4 p.m. each day during the 30 days of April. In her notepad, the doctor has this summary of the grouped frequency table. Calculate an estimate for the mean. It says, unfortunately, Dr. Khan has torn the page containing the table with her notepad and has lost some of the original data. Okay. So if there are 30 days in April and the number of days that the temperature was between 23 and 24 must make that total up to the 30 days of the month. There must be 10 days worth of data that she's tore the number off for. So the first thing I need to do is the midpoint of each of these groups. Halfway between 20 and 21 is 20.5. Halfway between 21 and 22 is 21.5. 22.5. And the last one, 23.5. To work out the mean, you need to do a multiplication of the midpoint and the frequency for each one of the categories. Once you've done each of those multiplications, you've got to find a grand total by adding up all of the answers that you're given. So 82, 172, 180, 235. A grand total would then be 669. To find the mean, that 669 has to be divided by all of the days of the month, so divided by 30, and that comes out as 22.3 degrees. Part B. What assumptions have you made in calculating an estimate of the mean from the hallway? So the assumptions have come about because I've been using these midpoints here. So I am assuming that each value in the groups or group, the temperature, is between the two values each time. So I'm assuming the midpoint is a fair representation, and the 4 days, for example, that are in this category weren't all 20 degrees exactly, but that some were 20, some were 21, and some were somewhere in between. So my assumption is that I've used the midpoints to represent the group. And we use the midpoints to represent the group to get a good estimation, but we don't know where between those two boundaries, 20 and 21 or 21 and 22, the actual temperatures lie. Part C. Farrell recorded the same temperature as her mother at 4 p.m. each day during April. She found that the actual mean in the hallway was lower than the correctly calculated estimate. Explain how this could be true. So as I was saying about the midpoints, if the actual means had all been less than the midpoint, our midpoint, although a fair representation, would have been an overestimate. Likewise, we could have had a temperature that was too high, too low, because the actual temperatures could have been above the midpoint. The midpoint is a fair estimate, but it isn't going to be as accurate as the raw data. So many of the temperatures that were recorded were less than the midpoint. So the midpoint has ended up being an overestimate. Okay? The temperatures were often towards the lower end of the group instead of being at the top end of the group, which is something that we assume when we do an estimate doesn't happen. So for that 1 mark, they're looking for you to acknowledge that this could happen, and in this case, it has.